So there are some selected questions, okay, on error and measurement, okay, which can help you to understand this topic. Let's start with this question. Question number 3 here. An experiment measures x, y, z, t is calculated by this relation here, which is t equal to x y square by z cube. If percentage error in x, y, z are this one, so what is it? Okay, so we know that like when we have this relation, so we can write the relative error, which is delta t by t is delta x by x plus 2 times delta y by y plus 3 times delta z by z. Now to find the percentage error, we can like multiply with 100, right? As we know that if we multiply by 100 to the relative error, so we get a percentage error. Now delta h by h into 100 is given as 1%. Del 2 times delta y by y into 100 is 3%. 3 times delta z by z is 2%. So what is it? 1 plus 6 plus 6, which makes it 13%. So option D is the answer. Let's see one more question, the similar question on this one. If you understood this last question, you can pause the video and can try that next question. Okay. The question number 4 says that the relation is z equal to a square b to power 2 by 3 divided by root c d cube. Okay, yeah. Now percentage errors are given, so I will start again by writing the relative error in delta z is equal to 2 times delta a by a plus 2 by 3 delta b by b plus 1 by 2 delta c by c plus 3 times delta d by d, right? So if we multiply with 100 in both sides, we'll get a percentage error. Now if we put the values of delta a by a into 100, that is 1% plus 2 by 3 into 3 by 2%, 1 by 2 into 2% plus 3 into delta d by d is, sorry, made a mistake, is 4%, sorry, I saw the last question. And the last one is 3 into 5 by 2%. Okay. So now we'll calculate this one. So 2 plus 1% plus 2% plus 7.5%. So 2 plus 2, 4 plus 5. Wait, I made a mistake somewhere. 2. Again, I saw the last question. It's 2%, right? Delta a by a is 2%. Yeah. So it is, which makes it 4%. So 4 plus 2 plus 1, 7 plus 7.5. So it is 14.5%. Correct? Yeah. So that is the option number B. So hope you understood these type of questions. Let's see some other type of questions. Question number 5 says that the dimensions of a rectangular block measured with a vernier caliper having least count is 0.1 millimeter. Least count is basically the property of an instrument, as we all know. Okay, and the least count is 0.1 millimeter. So the corresponding error will be 0.1 millimeter, which we call as a least count error. So this error will be present in all the measurements measured from that same instrument. So here the V is the volume of a rectangular block, which we can say as a cuboid. What is the volume? LBH, length into breadth into height. So if we write that relative error, so delta L by L plus delta B by B plus delta H by H. Now if we multiply with okay, let's calculate first. Delta V by V is delta L, delta B, delta H, all are measured from that vernier caliper. And the least count is 0.1. So 0.1 by 5 plus 0.1 by 10 plus 0.1 by 5. Delta V by V is equal to, it is 0.02, 0.01 plus 0.02, which makes it 0.05. And by multiplying with 100, we get a 5%. So option A is correct. And let's see the next one. For a cubical block, error in measurement of site 1%, error in measurement of mass 2%. What is the maximum error in density? So density is mass by volume. So if we write delta D by D is equal to delta M by M plus delta V by V. Now the point is, there's a one problem that we don't have a delta v by v, but we have that shape of the object and we have a error in sides. So we know like the volume of a cube is a cube, okay, where a is the side. So we can write delta v by v as 3 times delta a by. Now we'll substitute of this one. So it is now 3 times delta a by a. Now we'll multiply with 100 and the percentage errors are given. So delta m by n into 100 is 2% plus 3 into 1%, which makes it 5%. So again 5% is the answer. Option B is correct. Okay, so these kind of variations can all be there. Okay, this is like volume of a sphere, volume of a cylinder. So just try to write the relative error in volume of sphere, volume of a cylinder, okay, volume of a cone, okay, right, cuboid and cube we have done, right? So just practice writing volume and the surface area also. Okay, let's move to the next question. Okay, so in this row we have another question number 9, which is related to the resonance experiment, resonance column. The question says the tuning fork of frequency 340 has as a tolerance 1%. The tolerance basically is called as a percentage error in that particular quantity. So frequency has this tolerance, that means delta f by f into 100 is 1%. Correct. So used in resonance column, this is the formula of speed. First and second resonance are given. We need to find that percentage error in speed. So we'll start with the formula. V equal to 2 f naught L2 minus L1. Now we'll write delta V by V is equal to delta f naught by f naught plus delta L2 minus L1 by L2 minus L1. So delta V by V is equal to delta f naught by f naught as it is, and the error in difference is nothing but this one. We know that we write the plus sign only because we write the maximum error. Now we just calculate this value separately, because if you multiply with 100, so we can simply put the values of this thing. So we can calculate it separately. The delta L2 plus delta L1, L2 minus L1, which is delta L2 and delta L1 are 0.1 and 0.1. I already explained this thing. As you know that when the measurement is written, so we can write the error from the measurement. So error in both the measurement is 0.1 centimeter. So 0.1 plus 0.1 divided by L2 minus L1, which is 50.0. So which makes it 0.2 by 50. So now if I put the value here and multiply by 100, so what we'll get from here, so basically it is 0.2, it's 2 times, so 0.4 it is, right, 0.4%. So I'll multiply with the 100 now in both sides. अब delta f naught by f naught into 100 is a percent, the tolerance, which is 1%, and this value is already calculated here, 1.4%. So if we add them, so we'll get a 1.4%. So option B is the correct answer. Now we see the another question number 10, which is related to the equivalent resistance. So we know like the formula, the two resistors are connected in series, so R equivalent is R1 plus R2. And if they are connected in parallel, so 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Okay, I'll do this question here. You can try the same with the same data. You can try this parallel combination. Okay, so delta R equivalent is equal to delta R1 plus delta R2. Now we need to find the equivalent resistance. So these things like we need to find. So like if we calculate delta R equivalent is 0.5 plus 0.3, which is 0.8 ohm. And what is R equivalent? The true value, which we can calculate, 24 plus 8, which is 32. So now this is the error and this is the true value. So what is that equivalent resistance? So that we can say is 32 plus minus 0.8 ohm. Okay, so these, okay, so this is, okay, sorry, I did in series combination. Okay, this one is written in parallel. Okay, yeah. So anyway, I did for series here. Okay, you can try with the parallel combination. I'll just help you to do this one. This is in series. Okay, you will not find the answer here, but in the question they are asking parallel. So we can say that 1 by R equivalent is, I'll just help you to write the error. Okay, you can try it. So 1 by R equivalent will be equal to, just think about the differentiation. So 1 by h differentiation is minus 1 by h square. So it will be written as uh, like delta R equivalent by R equivalent square is equal to delta R1 by R1 square plus delta R2 by R2 square. Okay, so this is the like thing like which you can calculate here, and just put the values and just try to solve. Obviously, hopefully you will get the answer. Okay, so and right, so you need to find the delta R equivalent and R equivalent. So delta R equivalent you can calculate from here. Okay, delta R1, delta R2, R1 square, R2 square, and multiply with this one in the end, because you need to find this one. And from this formula you can find R equivalent, and then you can report the answer. Okay, so you'll get the answer C, definitely. Okay, let's move to the next question then. Okay, next question is question number 11. A person measures the depth of a well by measuring the time interval between dropping a stone and receiving the sound of impact. The error in his measurement of time is delta t, and he measures the depth of the well. Okay, L is equal to 20 meter. The acceleration is g, is given, velocity of sound is given, fraction error delta. So now, so first off, from the kinematics, we'll calculate the time interval here. So first of all, when he drops the stone, this is the depth of the well, which is L. So we can say, let's say it takes t1 time first of all when it hits the water. So L is equal to half g t1 square from the second equation, right? So t1 equal to root over 2L by g, that we can write. And when the sound is generated, the sound travels back with the speed of it, speed of sound. And in this case, the speed of sound Vs is equal to, again it travels the same distance L but takes t2 time. So t2 is equal to L by V. Let's write V only. Okay. So t1 plus t2 is the time interval, which is root over 2L by G plus L by V. And that t1 plus t2 can be written as capital T. Now the thing is like we need to find delta L by L. Okay, the L by L is unknown. Okay, and which is on the right hand side. Okay, so every time like if this kind of situation comes, first of all, that the known variable is on the left hand side, unknown variable is on the right hand side. So try to bring the unknown variable on left hand side and known variables on the right hand side. Okay, that's what like the procedure is. But the point is like we cannot solve the L. Okay, we cannot like it is in root here, it is in like in linear form, so we cannot like separate the L value. So what we'll do here, so we'll go with the general method, differentiation. Okay, because we know like all the error formulas come from the differentiation, right? So we'll differentiate this equation. Dt is equal to root over 2 by g constant, root L is 1 by 2 root L dl plus dl by v. Now you can see here dl can be separated. So we'll separate the dl here. So dl is equal to, if I take dl common and like I'll write one more thing, one more step. dt is equal to 1 by root over 2gl into dl, yeah, like plus 1 by v into dl. So dl is equal to dt divided by 1 by root 2 gl plus 1 by v. So this is dl. Now we'll divide with L. So it is L. Now right up, now you can see right hand side all the known variables are there. Left side we have unknown. So dl by L into 100. So now if you put the value, dt is 0.01 divided by 1 by root over 2 gl. So and now you just solve it. Okay, definitely you'll get the answer. So 2 into g 10. Okay, into 20. So it will make a 20, 14, 400. So 220 will get 1 by 340, 300 sorry, into length of tube is 20. So when it's and multiply by 100. So when you solve this one, definitely will get the approximate 1% answer. So which makes the option D is correct one. Okay. So that's what like the question is. So this question is a good question, important one. So hope you understood this one. Now let's move to the next question. Question number 12 says that using the expression 2d sine theta equal to lambda, one calculates the value of d by measuring the corresponding angle theta in the range 0 to 90. The wavelength lambda is exactly known. Okay, so delta lambda is 0, that means, and that error in theta is constant. So as theta increases from 0 degree, the absolute error in d. Okay, so we need to find the error in d. So 2d sine theta equal to lambda. So we need to find d here. So lambda by 2 sine theta. Okay, so the unknown variable I kept on left hand side. Now again, just to find that error in d, so we'll differentiate. So lambda by 2. So differentiation of sine theta is 1 by sine square theta, then cos theta, d theta. Okay, or you can do like cosec theta. So differentiation of cosec theta, you can use it. So now if we calculate the fractional error here by d, if we divide by d to find the fractional error, and d is lambda by 2 sine theta. Lambda by 2 sine theta. So sine theta is cancelled, lambda is cancelled. So the point is that fractional error in d is equal to, we are getting is cos theta d theta divided by sine theta. Now it says that the theta increases from 0 degree. That means if theta increases, so sine theta value will increase and cos theta value will decrease. So denominator term is increasing, numerator term is decreasing. That means overall quantity will decrease. That means fractional error in d will decrease. Okay, so that we can say for sure. So option D is the correct one. Clear? So hope you understood this question also. Let's move to the next question. The next question, question number 13. The current voltage relation of diode is given by this relation, I is equal to e to power 1000 V by T minus 1. Where the applied voltage V is in volt, temperature. If a student meets an error measuring, okay, the measure the current of this one, 5 milliampere, 300 watt, will the error in the value of current. So here, obviously, like we cannot write exponential function is there. So we'll start with the differentiation. So di is equal to e to the power 1000 V by T and 1000 by T into dV minus 0. Right, so this is di. We need to find di here, but we'll calculate this first, this value here. What is the value of this one? What we can do here? So see, from this equation, I plus 1 is equal to e to power 1000 V by T. Now what I can do is, like, I can divide these two equations just to simply cancel out it. So di by I plus 1 is equal to what is left, right? So this e to the power will be cancelled out. So di is equal to 1000 into dV is 0.01 divided by 300 into I plus 1. What is I here? 5 milliampere, and 1 is 1 milliampere because that is given. So it is 6 milliampere. So when we solve this one, 1000 in 0.01, so it is cancelled out here, and it will like 0.2 is like 0.1, 0.2 milliampere is coming. Okay, so option A is correct. Clear? Let's move to the next question. Okay, question number 14. The following observations were taken for determining surface tension. The capillary diameter of capillary is this one, rise is this one, using G. Okay, possible error. Okay, possible error in surface tension. So T is equal to RHG by 2, it is given. So we can write T equal to RHG by 2 into 10 to the power 3. So this one, like, it's straightforward. dt by t is equal to dr by r plus dh by h. G is, we use the G value, this one, so we are not considering there is an error in G. Now let's just put the value of these two. So dt by t is equal to, dr is diameter 1.25 है तो 0.01 10 to the power minus 2. Okay, anyway, we are not going to write this thing. And what do we have here? R will be 0.625. Diameter is 1.25, so by 2 we have to use it. Plus 0.01 divided by 1.45. Okay, so we'll just solve this thing and multiply by 100. So 0.01 by 0.625 plus 0.01 by 1.45 into 100. Okay, so when I'll solve this one, I hope like we'll get the answer. Right, so you can try to solve this one and you'll get the answer 1.5%. So option C is correct here. Let's move to the next question. The next question, question number 15, says that R equal to 1 minus A upon 1 plus A to be determined by measuring dimensionless quantity A if the error in measurement is less than. What is the error in? Right, so we need to find delta R, right? So what we'll do here, we'll just simply differentiate. Okay, I hope like we'll get the answer from here. So if we differentiate here to 1 plus A whole square, 1 plus A, quotient rule I'm applying here, and 0 minus dA minus dA, and then we have a plus sign. Okay, anyway, I'll write the positive because maximum error we take the positive dA, plus sign, then V1 minus A, then dA. Now if we solve this one, dr is equal to dA plus A dA. If we multiply, open the bracket, plus dA minus A dA divided by 1 plus A whole square. So it is cancelled here and dr is coming as 2 times dA by 1 plus A whole square. So that's the answer. Yeah, straightforward. Right, so by differentiation we'll get the answer. Question number 16, we'll see. What is the question? In an experiment, the initial number of radioactive nuclei is 3000 and it's found that the 1000 nuclei decayed. Yeah, so this question gonna be tough one because there's a nuclear concept we have to use. So I'll just like brief first of all what is this n equal to n naught e to the power minus lambda. So we know that there's a radioactive decay, right? When there's a nucleus, okay, according to radioactivity law, okay, the nucleus decays over time and there's a lifetime, there's a half-life exist. Every nucleus decays just to get the stability, okay, and it decays as per the stability, like okay, where it can be stable, so it keeps on decaying. Okay, that's what the radioactivity law, okay, mota like kind of, right? So in this one, that the formula like which we use here, this is a law of radioactive. Okay, in this one, that n naught is mentioned here. Basically n naught is the initial number of radioactive nuclei and n is the number of radioactive nuclei remaining. That is important here. So in this one, that n naught value is 3000 and n value is the remaining. Okay, I will say that it's from the 1000 plus minus 40 decayed. So if I say that take the true value only, so 1000 is decayed, that means what is left? 2000. So n value is going to be 2000. Now let's differentiate this equation now. So dn equal to n naught e to the power minus lambda t and t into delta lambda. Now we want to remove this term, so what I'll do here, we can do the division, right? That's 1 second. We have, what we need to find is error delta lambda. Okay, so yeah, we can divide here delta lambda. Okay, that's what is just 1 second. Yeah, yes, 2000 t delta lambda, like basically delta lambda we need to find. So if I just anyway, what do we just divide the equation? Let's see what it comes. So n by dn is equal to t into delta lambda, right? What is n here? It is 2000, and dn, what is dn here? That error index is 40. Okay, so I hope like we should get the answer. So n is 2000 divided by dn is 40 is equal to delta lambda. T will put here. What is time here? Time is 1 second, delta lambda. Let's see, do we get the answer? Delta lambda is 1 second. Yes, no, we'll just a mistake here. Just 1 second. Wait. Sorry. Yeah, division is wrong. N by dn, the right hand side will be having 1 by t delta lambda, right? Yeah, okay. So should we get the answer? So it is 2000 divided by 40 is equal to 1 by 1 into delta lambda. So what is delta lambda is 40 by 2000. So it is 0.02, and that is coming right. Option C is correct. Yeah, so that's it. So hope you understood this question. Let's move to the next one. Okay, in the same rule, like another question number 17. The energy is given as a square e to power minus alpha t. Alpha percentage error a is given, time is given. Okay, we need to find percentage error. Okay, so now I think like so far you understood the pattern. Okay, whenever you get to this exponential, yeah, any log kind of functions, just start with the differentiation. So differentiate dE is equal to, okay, here a and time, okay, variables are there, so we'll apply the product rule. So a square e to power minus alpha t alpha delta t plus e to power minus alpha t 2a dA, and then we'll divide this one just to remove this exponential. So when you'll divide them, so you'll get alpha delta t here, and you'll get 2 dA by a, and then multiply by 100. So now just put the value. Alpha is 0.2 into delta t. Okay, percentage error in time is given, right? That means delta t by t into 100 is 1.5. So delta t value is what is it? So delta t into 100 we have, so which is 1.5 into t. T is 5 plus 2 times dA by a into 100, which is 1.25. Okay, so we'll just multiply here. This is 7.5, which means 15, 1.5 plus, and yeah, they have not 2.5, so which means 4%, and the 4 is the answer. Okay, it's a numerical value question, so 4 is the answer. Okay, let's see the next question number 8. Question 18 is like kind of straightforward. The density is measured here. Maximum error in density, relative error is measured mass and diameter. Okay, so we have done like this cuboid question, if you remember, like the volume. So that's what the same thing we'll do here. D equal to mass by volume. So delta D by D is equal to delta M by M plus delta V by V. Up the thing is like we have a mass and we have a diameter, so we need, so volume will use, what is the volume of a sphere? 4 by 3 pi r cube. So delta V by V is 3 delta r by r, right? And we have a diameter, right? So we can say, see, diameter is equal to 2r, right? So delta, yeah, okay, I'll use another variable. Let's say capital D is equal to 2r. So delta D by D will be written as, what will write? Delta R by R, yes or no? So that means delta R by R can be replaced with 3 times delta D by D. So no change will come. So now delta D by D is equal to delta M by M is, now just multiply with 100 and we'll get the answer. So delta M by M into 100 is 6% plus delta V by V is 3 times delta D by D, which is 1.5%. So 6% plus how much is it? 4.5%, which makes it 10.5%. So answer of this one is 10.5. Okay. So these are the like selective questions which I think like very might be helpful for you for preparation of exam. So all the best, and just do well in the exam. Okay, so thank you for watching. Yeah.